Hello guys, this is Miss Berto here. Today you guys are going to learn about composite figures. And if you read the introduction to today's objective, a composite figure is just a figure that is composed of two or more figures. So again, a composite figure is just going to be two or more figures within one. And they're just composed together. So in this example, they're asking us to find the area of just a shaded region. And I put the steps here just to make sure that you guys understand what I'm doing. And I will also include it underneath the video so that you guys keep those steps in mind. So to find the area of the shaded region, the first thing that the steps is telling us to do is to identify each figure within that composite figure. I clearly see that this is a composite figure because it's composed of what seems to be two or more figures. And I see a rectangle and what seems to be half of a circle. Okay? Again, this is a rectangle and half a circle. However, the shaded region is not the entire rectangle. It's just a piece of the rectangle, not including that half of the circle. So then the second step says to identify the necessary area formula for each figure. So I'm going to quickly write those down, and you should all remember or go back into your notes what the area of a rectangle looks like. So it's just going to be base times height, and I'm just going to put this here to remember what those are. And then the area of a circle will be pi r squared. Okay, so I know I need to deal with those two formulas. Now, the third step says to understand what they're asking you for and to write the formula that you need to work with after. So again, what are they asking us for? They're asking us to find the area of a shaded region, and the shaded region is here, which is almost the entire rectangle, but not really. I have to subtract what seems to be half of a circle. So I'm gonna write down that formula. It's gonna be area equals the entire rectangle, which is base times height, minus, because I have to subtract, it's not the entire rectangle, minus the area of what seems to be half a circle. So I can just put half area of a circle, which is pi r squared. You could have also just found the area of the circle and then divided by 2, an entire circle and divided by 2. You can do it that way too. And then subtract that from the base times height of the entire, or the area of the rectangle. You can do it in different ways, but let's just do it based on what the steps is telling us to do. So I just wrote down the formula, and then I'm going to substitute the values that I should have or that were given to me in the problem, and then I'm going to solve for that area. So I have area equals base times height of the rectangle, and that includes this piece right here, right? Don't forget that rectangles, opposite sides on a rectangle are congruent. So this 50 here is also here, and 30, which is your height, will also be congruent to this side. So this is also 30. So I have base times height, 50 times 30, minus half pi times the radius. Now be careful with your radius. Yes, this is 30 here, but that is the diameter. Okay, so the diameter is 30. Therefore, the radius has to be half of that. Be careful, okay? Do not confuse the diameter with the radius. So I have, let's make sure you guys can see this. Radius 15 to the second power. Now I'm going to just do the simple math here and make sure I get that area. So 50 times 30, you can put all that in the calculator. Do it real quick. Area is 1,500 minus half of the area of the circle. And you can do it one step at a time. Half pi times 225 and I'm just putting it in a calculator. You can do the multiplication here divided by 2. There's different ways of doing this. And I like to do it this way. That is 353 when I divide it by 2. And then I subtract. Pam does. Subtraction last. And the area is approximately 1,147. And don't forget your units. So that's feet squared. Okay, so again, to recap, quickly going over the steps. First, you identify your figure or each figure, because there's going to be 2 or more figures within one. Then you identify the necessary area formula for each figure. In this case was the area of a rectangle and the area of a circle, and the formulas for those are right here. And then I went back and read the problem to understand what they're asking me for. They only need the area of the shaded region. So I wrote down the formula this way, which represents the area of the rectangle minus half of the area of the circle. Then I substituted the values into that formula and I solved. Shoot me a text or an email if you have any questions, and good luck with your work.